Ever pondered why we haven't found extraterrestrial life yet, given there are billions of stars in our galaxy alone? This riddle, known as the Fermi paradox, is a cosmic contradiction. It juxtaposes the high probability of alien life, suggested by the sheer number of stars, with our lack of contact or evidence. It's a question that has puzzled scientists and space explorers alike for years. Welcome to the exploration of the Fermi paradox and its exciting new solution. In the simplest terms, the Fermi paradox is a question of odds. It's like walking into an infinite cosmic casino and finding all the gaming tables deserted. The Fermi paradox is named after physicist Enrico Fermi, who during a casual lunchtime conversation with colleagues in 1950 famously asked, "Where is everybody?" He was referring to extraterrestrial life. With an estimated 200 billion galaxies in the observable universe, each containing hundreds of billions of stars, the odds of Earth being the only planet with life seem astronomically small. This is where the Drake equation comes into play. Formulated by Frank Drake in 1961, this equation attempts to estimate the number of civilizations in our galaxy, the Milky Way, with which we could potentially communicate. The equation considers factors such as the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, and the lifespan of such civilizations. However, the Drake equation presents a contradiction. Even with conservative estimates, it suggests that there should be a significant number of civilizations out there. This is the crux of the Fermi paradox. If there are a multitude of civilizations in the galaxy, why haven't we detected any signs of them? Why is it so quiet out there? This paradox presents a compelling puzzle. It's as if we've thrown a grand cosmic party, sent out the invitations across the galaxy, but no one has shown up. Or perhaps they did, but we just don't know how to recognize them. This is the question that has baffled scientists for decades and continues to ignite our curiosity. So, given these numbers, where is everybody? It's a question that echoes through the silent expanse of space, bouncing off distant galaxies and back into our telescopes, unanswered. It's a question that challenges our understanding of life, our place in the universe, and the nature of existence itself. It's a question that, despite our best efforts, remains as mysterious and elusive as the stars themselves. Scientists have grappled with potential solutions to the Fermi paradox for decades. This paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence or contact with such civilizations, has puzzled thinkers since it was first posed by physicist Enrico Fermi in the mid-20th century. The zoo hypothesis, for instance, suggests that we're like animals in a vast cosmic zoo, with advanced civilizations consciously avoiding contact to allow for our natural evolution and development. Picture this: an uncontracted tribe in the Amazon, blissfully unaware of the bustling world beyond their forest home. Could we be oblivious to the galactic civilizations beyond our tiny blue planet? Then there's the Great Filter theory. This proposes that all advanced civilizations inevitably destroy themselves before they can reach out to others. The idea is that there's a sort of cosmic speed bump, a barrier to advancement that no civilization can surpass. Whether it's nuclear war, environmental disaster, or a technological singularity, this filter wipes out civilizations before they can ever make contact. A chilling thought, isn't it? Lastly, we have the rare Earth hypothesis. This theory posits that the conditions necessary for intelligent life are so incredibly specific and rare that Earth might be one of the few, or perhaps the only, planet that has ever hosted life. It's a humbling theory, one that puts us in a privileged, unique position in the universe. Each of these theories presents a different take on the Fermi paradox, each with its own set of implications about our place in the universe. Some are optimistic, others not so much. Some suggest we're part of a greater cosmic community, others that we're utterly alone. Yet none of these theories have been universally accepted until now. The groundbreaking new theory proposes a fresh solution to the Fermi paradox. What if the reason we haven't made contact with alien civilizations is not because they don't exist, but because they're avoiding us? This new theory, coined as the zoo hypothesis, offers a different perspective. Unlike previous theories, it doesn't assume that extraterrestrials don't exist or that they've self-destructed. Instead, it suggests that they're consciously choosing not to interact with us. It paints a picture of a universe where we're akin to animals in a zoo, observed by advanced civilizations but not directly interacted with. Imagine a cosmic prime directive, where advanced civilizations have agreed to let younger species like us evolve without interference. It's a concept that flips the script, from us seeking them out to them purposefully hiding from us. This could explain why our search for extraterrestrial intelligence has so far been met with silence. The implications of this theory are profound. It suggests a universe teeming with life, but one where we are not yet ready to join the cosmic community. It's a humbling concept, and one that reframes our place in the universe. But like any theory, it's not without its critiques. Some argue that a universal agreement among all advanced civilizations seems unlikely. Others point out that it's impossible to prove or disprove, leaving it in the realm of speculation. Yet, this theory has captured the imagination of many and has opened up new avenues of thought. It's a reminder that the universe is vast and mysterious, and that we're still in the early stages of understanding our place within it. So we find ourselves back at the drawing board, grappling with the silence of the cosmos. Is the zoo hypothesis the answer to the Fermi paradox, or is there another solution waiting to be discovered? Could this be the answer we've been looking for? As we continue our cosmic journey, only time will tell. This new solution, however, isn't exactly comforting. It's like opening a door, expecting to find a room filled with people only to discover an empty space. Suddenly, we're faced with the stark reality that we might be alone in this vast universe. The silence of the cosmos, previously an enigma, now carries a chilling implication. The new solution to the Fermi paradox suggests that the reason we haven't heard from extraterrestrial life is that advanced civilizations may not exist at all. This could mean that life, as we know it, is an incredibly rare or even unique phenomenon. It's a daunting thought, isn't it? The idea that out of the billions of stars with their orbiting planets, we might be the only ones here. Imagine the impact on our understanding of life and our place in the cosmos. If we are indeed alone, it would mean that life on Earth isn't just special. It's extraordinarily precious. Every species, every ecosystem becomes even more vital to preserve. Our responsibility as custodians of this world would take on an entirely new level of importance. On a more personal level, this potential loneliness in the universe could shift our perspective on our own existence. It might challenge us to find meaning and purpose not from external sources, but from within ourselves and our relationships with others. However, let's not forget that this is just one possible solution. The universe is vast, and our understanding of it is still growing. It's entirely possible that we're merely looking in the wrong places or at the wrong times. Or perhaps we're not yet technologically advanced enough to perceive or understand the signals being sent our way. So while this new solution may seem disheartening, it's also a call to action. It's a reminder that we need to keep searching, keep learning, and keep pushing the boundaries of our knowledge. So as we continue our search for extraterrestrial life, we must also consider the implications of what we might find or not find. In our quest to understand our place in the universe, the Fermi paradox presents a tantalizing mystery. As we draw our discussion to a close, let's take a moment to reflect on the intriguing journey we've traversed. We started with the Fermi paradox, that has been perplexing us for decades. Where is everybody? In a universe teeming with billions of stars and potentially habitable planets, the silence is deafening. We then explored the various solutions that have been proposed over the years. Some suggested that extraterrestrial civilizations might have destroyed themselves before reaching out, while others proposed that they might be avoiding us intentionally. These solutions, while plausible, left us with more questions than answers. Then we delved into a newly discovered solution: This solution postulates that we might be in a cosmic backwater, a less populated region of the universe, and hence we haven't encountered any extraterrestrials yet. This theory, while unsettling, offers a fresh perspective on our cosmic solitude. Lastly, we discussed the profound implications of this new solution. If we are indeed in a cosmic backwater, it might mean that we need to reframe our understanding of our place in the universe in our attempts to reach out to extraterrestrial civilizations. As we gaze at the stars and wonder about our cosmic neighbors, remember sometimes the silence speaks volumes.